And then we have proof by contrapositive. So sometimes it can actually be really difficult to use a direct proof or a negation proof. In those cases, we actually use proof by contrapositive. So if we are trying to prove that if something is true, then it implies something, what we might actually show is the contrapositive, or the opposite. That if B is not true, then it implies that A is not true as well. So this is actually a little bit of a complicated proof, and you will go through that in a lot of detail in class. And obviously we'll go through tons of examples when you start school, just looking at, how everything works, and how we use all the proofs, when we use them, all that sort of stuff. Currently, we're just looking at the different types of proofs. So we're not going to go through them in a lot more detail, but here is an example that we prove by contrapositive. So prove that for A being an integer, if 5A plus 1 is an odd number, then A must be an integer. Not an integer, an even number. So now to prove the opposite, which is or prove by contrapositive, what we will start off with is A being an even number. So if A is an even number, or A is not an even number, then 5A plus 1 is not an odd number. So it's the contrapositive. So the contrapositive statement is if A is an odd number, so we're saying that it's an even number, now we're saying it's an odd number, then 5A plus 1 must be an even number. So proving by contrapositive. Okay. So here is the proof. Let's just look at it in a little bit more detail. So what we have first done is we have let A equals 2k1 plus 1 for k1 is all integers. So multiplying 2 by any integer plus 1, if we know, so what we are assuming is that A is an odd number. So multiplying an odd number by an even number will give us an even number, plus 1 should give us an odd number. So 5A plus 1 is equal to 2k plus 1 minus plus 1. Sorry, I think that's a typo. It should just be plus 1 here. Ignore that. So 10k1, so we've just substituted what A is. 2k1 plus 1, and we're just letting k1 be an integer. 10k1 plus 5 plus 1, which is equal to 10k1 plus 6, to 5k1 plus 3. So we just simplified that, and let k equal to 5k1 plus 3. So k is equal to 5k1 plus 3. We know that will be an integer because we're only dealing with integers, as k1 is an integer. So 5a plus 1 is equal to 2k, where k is all integers. So that is basically our proof there. So we've basically proven that we've just let k1 be an integer, and we're letting a be an odd number. So 2 times any integer plus 1 will give us an odd number, always, regardless of whether k1 is even or odd. So A we know now is an odd number, and that is what we're trying to prove. If A is an odd number, then 5A plus 1 must be an even number. That is what we want to end up with. 5A plus 1 is an even number. So we've substituted 2k plus 1 for A, and we just basically simplified that. So we get 5A plus 1 is equal to 2 5k1 plus 3. And basically what we've done is, instead of having 5k1 plus 3, we've just let k be equal to 5k1. Just to sort of simplify it. And then k is equal to 5k1 plus 3, which is an integer. We have to show that it is an integer because we're dealing with integers, as k1 is also an integer. And then finally what we've ended up proving is that 5a plus 1 is equal to 2k. So 2k, so 2 times anything will give us an even number. So therefore 5a plus 1 is an even number, given that k is an integer. So therefore we have ended up proving what we were intending to prove, and using a contrapositive statement has just made it a lot more easier for us.